What is inductive effect? Firstly, let me teach you one important question. How covalent bond is formed? Well, we all know that by mutual sharing of electrons, covalent bond is formed. For example, consider hydrogen and fluorine atoms. We know that hydrogen and fluorine will share one electron each to form a covalent bond. Thus we learn that covalent bond is formed when a pair of electrons is mutually shared between two atoms. Now what is inductive effect? Well, consider this covalent bond between hydrogen and fluorine. We know that this is shared pair of electrons between these two atoms. Now fluorine is more electronegative and hydrogen is less electronegative. Remember that electronegative means attracting shared pair of electrons. Here, fluorine attracts the shared pair of electrons toward itself because it is more electronegative. As a result of this, the electronic cloud would tilt more towards fluorine than hydrogen. So partially negative charge appears on fluorine and partially positive charge appears on hydrogen. Now listen carefully. This shifting of electrons towards fluorine is known as inductive effect. Therefore, we define inductive effect as the shifting of electrons from low electronegative atom towards high electronegative atom and a covalent bond is called inductive effect. Let me repeat it. The shifting of electrons from low electronegative atom towards high electronegative atom and a covalent bond is called inductive effect. Here, this fluorine is known as electrons withdrawing group and we represent it by negative I, while this hydrogen is known as electrons releasing group and we represent it by positive I. Here, let me teach you one important MCQs. Inductive effect is dash effect, temporary or permanent. Well, the answer is permanent. Inductive effect is a permanent effect. Thus remember that inductive effect is the shifting of electrons from less electronegative atom towards more electronegative atom. Now let me teach you factors affecting inductive effect. Well, the first factor is distance. When the distance increases, inductive effect decreases. For example, consider this compound. This is first carbon, second carbon, and fourth carbon. We know that chlorine will attract shared pair of electrons towards itself. So partially negative charge will appear on chlorine and partially positive charge will appear on this system. Now this second carbon is away from chlorine, so less positive charge will appear on it. This third carbon is more away, so very less positive charge will appear on this carbon. Note it down that the inductive effect on 4 carbon is negligible. So inductive effect decreases when distance increases. Secondly, degree of carbon. For example, consider these compounds. Here, this carbon is bonded to one carbon. So it is 1 degree carbon or primary carbon. Secondly, this carbon is attached to 2 other carbons. So it is 2nd degree or secondary carbon. Thirdly, this carbon is attached to 3 other carbons. So it is 3rd degree or tertiary carbon. Remember that inductive effect of tertiary carbon is greater than inductive effect of secondary carbon and more than inductive effect of primary carbon. Thus note it down this order of increasing inductive effect. Thirdly, hybridization. Inductive effect of sp is more than sp2 and sp3. For example, consider this compound. We can see that this carbon is sp3 hybridized, this carbon is sp2 hybridized, this carbon is sp2 hybridized, this carbon is sp2 hybridized. Now this group is negative I or partially negative charge will appear on it because it is sp hybridized, while this carbon is positive I or partially positive charge will appear on it because it is sp2 hybridized. Thus note it down this order of hybridization. Lastly, let me teach you negative I affecting groups and positive I affecting groups. Remember that all functional groups are electrons withdrawing groups are negative I groups like OH, CO, Cl, NH2, Cn, etc. On the other hand, all alkyl groups are electrons releasing groups are positive I groups like methyl, ethyl, propyl, etc. Also remember that methyl has less inductive effect than ethyl and ethyl has less inductive effect than propyl. The easy trick is, the more the number of carbon is, the more is the inductive effect. Hence note down all these important points. Finally, let me teach you that how we can solve inductive effect questions. Well, consider these compounds. In this case, we know that halogens are more electronegative. Chlorine will attract the shear pair of electron. Thus chlorine is electron withdrawing group or negative I, while this is electron releasing group or positive I. In this case, OH is a functional group, so it has more inductive effect or it is negative I group. On the other hand, this is positive I group. In this case, NH2 is a functional group, so it has more inductive effect or it is negative I group, while this is positive I group. So note it down these questions. Now let's consider these compounds. Which atom of halogen has more inductive effect? Well, we already know that fluorine is more electronegative than chlorine, while chlorine is more electronegative than bromine. Hence, the inductive effect of fluorine is greater than chlorine and bromine, while the inductive effect of chlorine is greater than bromine. So note it down this question. Now consider these compounds. Which chlorine has more inductive effect in these compounds? Well, we know that this is chloroethane, this is isopropyl chloride, and this is tertiary butyl chloride. Here, this chlorine is bonded to 1-methyl, this chlorine is bonded to 2-methyl, and this chlorine is bonded to 3-methyl. We have already learned that the more the number of carbon is, the more is the inductive effect. We can see that there are more number of carbon in tertiary butyl chloride, so it has more inductive effect than chlorine of isopropyl chloride. While chlorine of isopropyl chloride has more inductive effect than chlorine of chloroethane. Hence note down this important question. Finally, let me teach you one bonus question. Consider this compound. Can you guess the electron releasing and electron withdrawing groups? Well, we know that metals like calcium are electropositive and halogen like chlorine are electronegative. Here, this is electron releasing group or positive I group, while this is electron withdrawing group or negative I group. Therefore, remember that in case of a metal atom, the group of halogen becomes electron releasing group. I hope that you have learned all about inductive effect.